So Google just made one of the most powerful AI agents it has ever built available to all of us. And it is called AlphaEvolve. And as of this week, you can actually start using it yourself in Google Cloud. Here is what AlphaEvolve is in plain, simple English. It is a specialized coding agent that uses evolution to crack the problems normal code or programs cannot. Think of algorithm discovery, mathematical search, brutal optimization. The stuff where the number of possible answers is so astronomically large that no human and no normal program could ever check them all. So you hand it a working but let's say mediocre piece of code as well as an objective. You provide it a way to score the code, right? And it reads better and better versions generation after generation until it lands on a solution nobody has written. It doesn't just spit out insights or recommendations, it actually writes almost a net new algorithm. And I don't say powerful lightly, right? This is the thing that wrote part of the scheduler running Google's entire data center fleet, clawing back around 0.7% of Google's worldwide compute. That is huge. It even sped up the training of Gemini itself, the model it itself is running on. So later in this video, I'm going to show you two things. One, a custom app that I built to explain this and run it live. I will hand it a real forecasting problem, give it an objective, and we will see AlphaEvolve win that competition. A quick clarification up front because I know this tripped a few of you last time. So this UI, whatever you will see, is mine. I built it. So it's not something Google ships. AlphaEvolve is actually a headless agent, right? So it has no app, no button, no chat window anywhere. You drive it with code. So I just built a face on top so that we can actually see how it works and you can understand it better. Now, the other thing that I will also show you in the video is how to switch it on yourself as an API in your own Google Cloud console, right? What are the prerequisites, the setup, the whole path. So to be clear, AlphaEvolve isn't new. What changed is that it's now a public API you can call. That's the unlock. The thing that redesigned Google's own chip is now something you can point at your problem. And it's not a lab toy either, right? So there are a lot of companies who have already used it. For example, Coolblue used it for demand forecasting to cut their error. FM Logistic took 10% off routes that were already optimized. So I'm going to be using a demand forecasting problem as part of the demonstration. So now that you understand at a high level what this is and how companies are using it, it's time to see it in action. So a quick disclaimer, all opinions are my own and do not belong to my employer. All right, with that, let's get into it. All right, so what you're seeing over here is the UI that I actually built in order for us to understand AlphaEvolve pretty much in deep. And I will also talk about the architecture in a few seconds from now, which will also help you to understand what are the components that you need from your end in order to make this work. But what I want to do here is I want to actually start with the business problem so that we can all relate to it. So I've taken a demand forecasting problem, which I think all of us can relate to. And here is the data that I've taken in order to run this demand forecasting problem, right? So you see this is like a 2-year data with really nice spikes and growing in demand, which is usually how a demand forecasting would work over the last 2 years. You would expect things to grow, right? And the way to think about AlphaEvolve is you will give it a particular existing code or a program, and you would expect that AlphaEvolve as an agent would look into that and evolve it to a much more optimized version of it, right? So that is the thought process. So if you look at, this is a program seed, and I'm going to be using like a forecasting algorithm. In this case, I'm using double exponential smoothing algorithm. And this is the baseline, right? So now I'm going to run the baseline, and you would see that it has given me an 11.2% MAPE, which is mean average percentage error. So you can see the error rate between the actual versus the forecasted one. So 11.2 is not that great. Generally, in the world of forecasting, you would want something which is at least in single digit and obviously upwards of 5. So that's what you're looking at, right? Now, what I'm going to do now is going to run the AlphaEvolve. But before we do that, I want to explain the architecture so that we can clearly understand how this works, right? So if you look at the architecture, it's like a tight iterative loop, and it splits cleanly between two sides, right? The part which Google runs and then the part that you run. Remember, this is an agent, right? An end-to-end agent. So there is a harness that comes along with it, right? So it starts with your side where you would provide three things. And this is why it is super important for you to understand. So you're bringing a seed, which is called program.py. So this is the seed program. In this case, this is the baseline forecasting code that I have given, right? So this is the seed program. And then it evolves from that to an evaluator, right? So this is the seed program, the thing it evolves from, right? So think about that as the baseline. And then you will also have the evaluator, which is evaluate that pi. This is how you score any candidate, right? So it loads my historical data, runs the forecast, and calculates the error, in this case, the MAPE. And then you have a controller, which is main.py, which orchestrates the experiment and talks to the cloud, right? So all three basically run on your side. Now, on the Google side, this is where AlphaEvolve engine resides, right? So this is a managed service powered by an ensemble of Gemini models. It has a prompt sampler that crafts smart prompts and a program database that stores every version it's tried, each with its score. So you would want it to continuously run and evaluate itself so that it keeps making itself better, right? So that's the idea, and that is the whole core, right? And here's the beauty to it, right? And this matters for everyone with sensitive data. The evaluator is completely customer managed. Alpha Evolve never sees your data. It only ever gets your score. So your data stays on your side. The AI just optimizes the logic, right? And integrating is genuinely three lines, as you saw here, right? So you will have to initialize the Alpha Evolve client. You define your experiment by handling it your custom forecast evaluation function. And then you kick off the run controller loop. And that's it, right? So the loop runs autonomously. The AI writes an edit, and then your evaluator scores it. Basically, the winner goes back in the database, repeat, and it could repeat multiple times until it lands on the algorithm we are about to watch it discover, right? So that is the broader algorithm. I hope this made sense, right? So the things on your side, things on Google side, which control what is seeing, if the Google side seeing data and stuff like that, and the three larger versions, right? So that's the idea. Now, if I go back to this, let me just do the baseline again. So we know that we are executing against 11.2 version. And then this is the objective that I'm sharing, right? So minimize forecast error on held out daily demand, right? So now I'm going to run the alpha evolve algorithm, right? So now what it is doing is it is creating a new Gemini enterprise session. This is where I was talking about that it requires the Gemini enterprise license. So it is going to do that. And then once it has done this, it will be able to write the evolved program that .py, right? So now it has done that. It is all live, which is going on, and it is writing the code over here. And it'll start writing optimized code once the execution has been completed, right? So we'll give it a few seconds for it to complete because it could take multiple angles. You can see that it has acquired one new candidate. And here it is generating the MAPE score, right? So it will keep on doing this. So now it is going in the second loop. So it'll keep on doing this till it is satisfied, right? So here it has got like another MAPE. The idea is it is evolving as it rightly says, right? So once it has finished the evolving, I've created the app in a way that I will see the evolved MAPE as well. So I'll come back and show you what that MAPE looks like, right? All right, so looks like the execution has completed and it has actually evolved the MAPE. So it has actually gone down from 11.2 to 7.1. And you can also see the forecast here, the comparison forecast here, which is pretty good, right? Compared to the initial seed, which was flat. And you can also see the evolution here, right? So it kept on producing different candidates and kept on forecasting against the 90 days. And it kept on doing this till it found the best possible output, right? And that is where it settled down on 7.1, which is still fairly good, right? Which is almost like 35% improvement directly. So that's what it has done. And what it has also written is actually the evolved program .py, right? So that is what I was talking about, that it generates the new algorithm from scratch, and that becomes the evolved pi, right? So if you again look at the architecture, you are only sending program.py, evaluate.py, and main.py. The output will be the evolved program.py, which is what you're seeing here, right? So that is what it generates, right? So that's a cool thing which comes out, right? I hope that this app really helped you understand what is happening under the hood and what are the things that you will need to take if you're working on this. What I would do now is actually open up GitHub as well as Google Cloud's installation instructions, and you will be able to then replicate this on your end as well, right? So let's do that. All right. So this is the blog post where they have explained and talked about making Alpha Evolve as GA. And this is really good information. You also see a lot of customers already using it and getting benefits. There are a lot of use cases that they have mentioned. At the end, they have actually mentioned the repo where you can look at the basic Colab examples to understand how this works. So that is exactly what I use. Let me open up that repo right now. So this is the repo that they're talking about. And in this case, these are the examples that they have already given. This is the circle packing example. And some of the examples are also advanced level, right? So you can basically do that. Some of the prerequisites that you need to be pretty clear, right? So the prerequisites are you need a GCP project, obviously, and then you also need a Gemini enterprise license. And then you need to have one Gemini enterprise license per system user who interacts with the API, right? So basically, you are enabling this particular API. And then there are a set of commands that you will want to run. You will need to create a service account and then assign like the discovery engine role to that particular service account. And then most importantly, you will need to enable this particular discovery engine API, right? So what I actually did was I cloned this repository and I basically worked with anti-gravity and asked it to help me with all of the installation and then help me with the setup, right? So I obviously have Gemini Enterprise license as well as I have a GCP billing enabled project. So I was able to do that. So that is what I followed. And then that these are the examples that were here. So let me just open up my anti-gravity and show you what I did, right? So these are all the examples that you saw in the GitHub repository. And in this case, I actually created my own. So you can see that I have this demand forecasting and I created this basically this data which you saw. And then this is the evaluate.py. This is the program.py where I've kind of used like a simple forecasting example, right? So this is the forecasting example. So I basically ran the evaluate program and the run evolution is something which got created after running that particular algorithm, right? So that's what I did here. But then you can basically test it out by the existing examples here, right? So this is the examples that have been given. And you obviously don't need to have a UI, right? So you can actually run this directly from the cloud CLI and they have given like clear instructions over here. You should be able to run it. So that's what I did first. But then I thought it'll be easier for me to explain this with a UI. So I worked with anti-gravity to create a UI. But under the hood, this is an API call, right? So there's no app, there is no UI that comes out with it. Basically, you're expected to call this API, AlphaEvolve API, and point it to an existing program and ask it to make it better by providing a success criteria and the objective, right? So that's the whole process of AlphaEvolve. Okay. So I hope this was helpful and it added value to your existing knowledge base. I think this is a pretty cool agent. I think one of the smartest ones based on what it has already solved. So I would encourage you to run some experimentation and leverage it and see for yourself if it is helping you optimize some of your existing challenging use cases. All right. So please let me know in the comment section if you have any questions. I had a lot of fun building this and understanding this. It was very interesting to read through this. And Alpha Evolve is now GA. So please go ahead and try it and let me know in the comment section what you feel about it. All right. I hope this added value. If you're new here, please hit that like button and do subscribe to the channel. And if you're existing, of course, please let me know in the comment section your thoughts. Thank you very much for your time. Thank you for watching, and I will see you in the next one.